Okay, it looks like we're live. So welcome back. Today I'm going to be continuing to work on KanoScript. And there we go. Yeah, finally in its own repo. Very happy about that. For sure. So, basically, what we have now is we have an executable, right? And we also have some options that we can do with it. So we have, the options are to compile or to run the program. And also to show this menu help. Don't worry about that. So we can compile a program. So say this one, rule110, right there. .kano. And that will compile it, yes, into rule110.10, right? And then we can emulate that if we use the Titanium runtime, right? The one that I made quite a while ago from the virtual machine. We can run it with that, and it will run. Or alternatively, we could just run the program, right? So instead of compile, type run. Alternatively, you can also just not put anything, and it will act as run. We can run that, and it will run the program as well. So that's basically what we have now. What I'd like to be able to do is at least some very basic type checking. Hey, how you doing? What is up? Yeah, so hang on a second. There we go. Yeah, some sort of type checking. So each expression basically is going to return a type, and then all the types, like for now, all the types are going to have to be exactly the same. Right, so you have to either have int plus int or something like that, right? It cannot be anything different, except probably with pointers, right? That might be a little bit different. Bright sunny day, hour left of work, finally the weekend. Yes, finally. Let's see. Okay, so that's going to be in the front end, in the parsing. How's the scripting line coming along? Pretty good. Let's see. So basically, the most complicated program that I've written so far is rule110. And so some way of parsing about it, like long if statements, like a bunch of those. But other than that, so I wrote this. You can see there's structures, variables here, arrays as well, functions, things like that. And then we can call it NOSU rule110. Yeah. So that was quite a while ago. I haven't written anything more complicated since then. I've also added some stuff, so now I should be able to simplify this as well. But yeah, it is going pretty well. Other than that, it's sort of just been like cleaning things up and such since the rule110 stream. Yes, for the most part, there's been a few other things, few features. But today I'm going to add type checking because right now, here if I make just a test file, I can do something like xint equals 3.0 plus string plus 4, right? And then that will not complain at all. So if I run that, an unexpected token, what the heck? I don't know what's unexpected. Hang on. And it inserted a null termination byte. Alright, yeah, so you can do that. And it doesn't complain at all. And it returns 4. So that's obviously not very good. So I'm going to, each expression is going to have a type, right? That is basically the idea. But yeah, I just took the integer and that's it. Yeah, obviously would like to complain about that from the compiler. So let's see. Primary. So each one of those is gonna actually, what do we have? So if I look at an expression, right? We have types, right? So that, but do we have a expert? We have the return type, so that's like the data type. Okay. So yeah, we need to set that for each one, whether it's an int or whatever, and then use that. Let's see. So dot return type equals token dot Actually, can I use that? Because that's really for not that, but just int typing. Actually, I'll call it data type. Let me make a new one because the other one is supposed to be given actually. Let's see, that's for. Oh yeah, so I'll have one of these, and this will be the data type. Okay. So yeah, each one of these, it's not going to be too difficult to figure out what it is. So a specific standard of C that you work with. I was watching Kindness talk about Modern C a few days ago, and it looks like there's some good stuff going on there. I do not have a specific one. I think, let me see what I don't remember if I set it in the makefile. Yeah, I do not use that. But like C23, there's stuff there that I don't think is out yet. Like it's not released, right? Yeah, but most of the stuff that I write, I think it is should what like C what's that one? Is it C99? I think it's pretty much compliant with that, except probably a few things like I think to do with structs. I don't think you can initialize a struct like that. However it goes, right? I don't think you can do that. But other than that, I'm pretty sure most of it is like pretty compliant, fairly. But I don't use a specific one. I would use whatever I know. Use target C plus 20. I don't think I'd want to work with the basic C plus plus 98. Yeah, C does change a lot slower. There is a lot of stuff in the C23 though. So once that's like released, because I don't think it's like all the features are released yet. There's some interesting stuff in there, so I might try that out. I think that could be cool. Yeah, and they have been working on it for a while, so it's probably already going to be pretty stable once it releases, right? Okay. Right, it's a pointer type. Do I have just a pointer type? Let me look here. Type pointer. Yes, that's what it is. Well, I do have type stir, so I'll use that. Okay. Primary. Let's see. Okay, yeah, something coming in C23 is booleans, like true and false, are now like built into the language instead of being in the standard library. So that's gonna be cool. Excited for that. And there's a few other things I don't necessarily remember exactly, but they were cool. Equals char. Okay, so that's the return type. So that is going to be a okay, what is this? Parse built in. Yeah, so we need to parse that. And then the dot data type equals value dot built. No, value dot yeah. Dot return type. Yeah, so it's gonna be the same thing as that. And you see, that's about all I picked up. To be honest, it was a pretty in-depth talk. Yeah, let me see if I can pull it up because there was C23. There was a good source for it that showed a lot of the things. I think it's CPP reference. Let me see. Yeah. So, yeah, CPP. Yeah. So there's some. This has. I can leave a link to that. It has pretty much most of the features. Let's see. So like, and I don't know what a lot of them mean. Like, they removed old style function declarations. So how does that work now? We'd like to look at that. But something else that was interesting was binary. Binary literals. Actually, that's not what it was. There was like binary literals, like which wasn't officially supported. So that's cool. I don't think that's what this is though. Okay. Yeah, but there's some cool stuff in there and preprocessor. Yeah, there was embed too. I saw that where you can embed into the binary like a file. That is cool. Let's see. Bit, alright. Yeah, I haven't read through it in a while, so I don't remember all the stuff. Mm, okay, okay. Hey Alavaz, got attributes now. Those are fun to litter on the code when you know them for compiler speedups. Alright. Back soon? Alright. See ya later. Oh yeah, very cool. How you doing, Alavaz? What is up? So this, it's an open parenthesis. Then, oh yeah, then we parse. That is, this does not need a type because the type gets returned from that. So when we recall that, it'll be checked there. Oh, let's see. So ident. So if it's a function call, then we have that. So we need the return type of the function. We should be able to get the function. Because we do append it to all the functions. So let me do function equals get funct. What do we have to pass there actually? Right, so we don't have all the functs. Is that what it's called? Is that what it is? Let me go to parts. So we have functions. Yeah, so I want to pass that anywhere that we call this. That's gonna have to update the whole thing. You are good. I am good as well. I could just, let's see. I don't really have a thing though. It's a bit unfortunate. It's gonna work as though it were there already though, and then I'll have to go through and fix all the places. But let's see. So this, we get the function, and we'll pass the functs, as well as what else do we need there? I don't know. I'll come back to that. But then we can use the beta type equals function dot type. I think it's just called type. Pretty sure. So let's see, what is all this? So close parenthesis, parse expression. Yeah, and I can pass the functs in there. So maybe I'll just call it that. That probably makes that'll be good. Functions, okay. Okay, let's see. So that should be fine then. Just append to that. Yeah, but then we also, I guess, can set the a.func_call.type equals function type as well. So we have that. So we have both of them, you know, the expression type and then the function call type, which we will use that as well. Expression. So we have this array. So we need to get that. Get the type. Alright, let's see. So this is dots. That's an expert field. So we have to get that. Yeah, we have to get all these. Okay. So this will have to get the turn type open bracket. So it's like this one. So that's an array. So we have to get the variable. Array equals get var from we don't have them yet, so variables. Right, so we'll have to do that, and then we can set the dot data type equals array dot type. Basically, is what we have to do there, and this will set that as well, and that should be an integer, so we'll have to check that. Okay, this type is an integer, but we'll get back to that. And then here is basically the same thing, so this could also be a switch statement. Anyway, so this is the field, or this will be the struct. Yes, this can be a struct. Let's get, and this can be a structure. Get struct, from the struct. And we want to set, then we need to get the variable from the struct. So how do we get that? Let's see, so then we need to basically just, type equals 0, so I set it to 0, and then I will iterate. So wall view compare structure dot field I. Well, we can do a for loop for that. Right, 0 while structure dot field I dot type. I think that's what it is. Does not equal, not the type, but the name does not equal the we need to get the name down here actually, so we can set it there. So yeah, we need to actually move this down a little bit to here. Get rid of this. Get rid of that actually. Does not equal the use view compare. I forgot. Okay, I'm a little messed up. So view compare does not equal this token.value.iden. Then we will do I++. So we need that, and then we should have that, so we can get the type. So we can set expr data type, because the data type of this is going to be whatever the field is. So data type equals structure.field I dot type. Okay. Then we have this one. So this is the value of the variable. So we have to get the variable. Variable var equals get var. And yeah, that's the variables. Then we can set the dot data type equals var dot type. Okay. Say, there we go. So this is not going to compile because there's a few things that we'll have to do. First of all, we need to pass the variables here. See, is that right? Get var. Alright, variables. I call it variables, so I will do that. Variables. Like that. Okay. And then we have some stuff. So 2 key arguments to parse primary. So anywhere that we call that, we need to pass it. So actually, I did parse expression. Yeah, so we need to update parse expression as well. All of those. Parse expression. And also variables and what was the other one? Functions. Yeah. Parse extra. Keep going. Functions and variables first. Variables and functions. Okay. Parse expert 1 is going to need the same thing. Functions, and variables. Okay. Parse expert. Variables, okay. Variables, functions. Parse expert. Let's keep going down. Down the road, let's see. 1. Okay, so parse expert 1. So then we have variables and functions. Variables and functions. Variables, functions. Variables, functions. Let's see, keep going. And these need to be pointers, so expert, variables, and functions. Same thing. There's gonna be a lot of these. Variables and functions. Yeah, and then once we anywhere we parse the expression, we're gonna have to check it. Here, okay. And functions. Variables and functions. Okay, so that's all of those. And we have parse. What do we call parse parameter? This should be the only place, I think. Okay, and here, obviously. And that is it. Okay, so now we have to update the header file as well. So let's export. Okay, then this one. Alright, that is wrong. 943. That's supposed to be a. There we go. Let's see. Variables undeclared. Okay. Where is that at? So variables is not in here. So parse does not have variables. Oh, it's called vars. Shoot. Shoot. Variables. Needs to be just called the vars. Okay. Vars. Okay. Right, there we go. That should be good. And let's see what else. So vars. Nodes pointer. Oh, shoot. That's not list of variables. That's not good. So, yeah. So I need to update all of these. So parse primary, we're there. And we'll change this to nodes. Parse expression. And here. No, that's wrong. Nodes. Whoops. That's that up. Nodes and. Okay. So then, functions undeclared. Why is that undeclared? It's 764. So we have no functions in here. And then, okay, so parse reassign left needs vars and functions. Okay, and that's it. Functions undeclared. 718. Okay, so one of these is just I have to pass the function. What is this one? Okay, same thing. Use variables, functions. Okay. Parse var dex. We do call that a few times, so. Vars and. Alright, so that should be good. Parse var dex, yeah, so that is the header file. So var variables and functions. Okay. And let's see, functions undeclared. 680, okay. It's native node. I think we only call that once or twice. Okay, and that is in here as well. So variables and okay, getting there. So there's a few other places before you have to do that as well. Range parameter funcs. Why is it called funcs? Wait, hang on, hang on. Parse primary. Parse primary. I want to call it functions. Okay. .589 is actually wrong. It needs to be a comma. I do that up here as well. Those are not right. Okay, let's see. So some of the things like get var is not valid, so I need to work on that. Where do we have get var? Is that a valid function? It doesn't say it's not. Get structure. Okay, get structure. Can I do that? Structure. Structure set but not used. Why? Okay, because I need to actually do that. Why don't I use it? Hang on. Structure.field. Is that invalid? Oh, it initialized it. Why is that invalid? What do I have to do from get var? So I think it's defined in here. Maybe it's not. Hang on. Wrong. Yeah, so we don't really have that, do we? Too few arguments. So that needs the name. Yeah, okay, so location. You say location, which we can pass that. The nodes of structs, and then the name. Okay, so we can get that. Structure. Okay, so the location is going to be expert location. I think we have that, right? And then also, we need the name. It goes here, so that is expert value.field.structure. Okay, and then we can just grab this and put it down here. And we should have the structure. Structure set for lines, but we do use it, so I don't know what that's about. Struct, okay, struct has no member named field, so what does it have? Let me look at struct. Oh, it has the values. Okay, so how can we iterate over the values? Alright, let's see, do we do that in here? That you guys structs. Is that right? Yeah. Okay, now how do we get the Howdy, how you doing? How's it going? How was your meeting? I find no format names, so that's what I need to do. You were stolen, you broke your pen. Dang. Wait, what did I do here? I need this. Let's see. Let's see. Structure.values.data I. That's what it's called. Data I. var.name. Okay. Let's declare I here, actually. See that? Okay. Let's see. Dot value, dot var, dot type. Okay. Next variable type. Where is? Oh, that's not here. Struct number name value. Yes, values. Previous definition of structure with type struct. Did I make it twice? Hang on. I did. Okay. Expert undeclared. expert. There we go. Get var. So we don't have that. It's gonna just be like that. So not type. Interesting. Okay, so get var. So we need to make a get var that can iterate over the variables and return it. So value.var. Okay, yeah, so we can iterate over those. Get var. So this needs the nodes variables, and then also it's going to need the string view. So for 0 y is less than variables dot count plus plus. And then I don't know what's up with the indentation. If we compare variables dot data I dot value dot var dot name with name, then we'll return not compare, we'll return the variables dot data I dot value dot var. Okay, otherwise we'll just assert, not assert, but we'll print an error. So we don't have a location though. So maybe we will pass a location. It's actually location. Print error, we can pass the lock, and then we can say unknown variable that, it's actually you print name. You are name. There we go. Okay, and that should work. So get var, 2qr needs to get var. So we need variable, well we need the expr location variables, and then the name, which is what I'm getting here. So let me just take this and move it back here. And then expr value array name. Whoops. Grab this. So expr data type equals array.type. Okay. Like that. Get var also is here. I need to do the same thing. Expr location variables and expr value dot variable. Okay. And dot data type. It's an error. Okay. Expr data type equals var dot type. Okay. Semicolon. Yeah, that needs to be actually like that. Here's variable type. Why do I do this? Yeah, I don't know. 579. Let's see. A function not type. It's just function not have type. Let's see. Oh shoot, I need a. Where is that? Right here. Does function not have? Do we get fine? Have it in here. Is it defined in here? Yes. So that returns a function. Iterates over functions and does that. Okay. Turns one of those, and the function does have a type, so that is all fine. Let's see, 579. So why isn't it like that? Let's see. Well, it's supposed to be actually. Incompatible types. Alright, it doesn't actually like the get func, so it's not included here. Yeah, so I need to actually define the get func. Okay. Functions as well as string read name for basically the same thing as this. But functions count. Functions.data I, not it. Dot name actually. And return pointer to functions.data I. Unknown function. Okay. Oops, that's not right. Get func declared here. Okay. This is functions. There we go. Wait, hang on. Perimeter function set but not used. I don't understand. What? Let's see here. Functions and then the name. Oh, back. And then exper data equals function. Exper value dot func call that type equals function. Okay, and here we go those, and there we go. Function call has no memory name type. Alright, what's it called? It doesn't have that, so we don't need to set that thing. Okay. Let's see. Function set but not used. Why is that? Okay, because I did it wrong. It's a fake pointer. Okay. Variables, it's actually the same thing. Whoops. Okay. And let's see. Location undeclared. We did not pass the location. Get func. Extra lock. Okay. No, I did that wrong. There we go. Okay. Alright, it's actually not even supposed to be a pointer, so let's pass it like that. That will work fine. Okay. Declared here. Do theorems to parse expression. Okay. Forgot a comma there. And we don't have functions here. And parse built in variables and functions. Might be the only place I would call that. Okay. Multiple definition of get func. Yeah, okay. So get func. So I will change the name. Function. Okay, that's fine. Does compile. You're gonna say Unknown variable A. Okay. Let's actually run on Kano. And that one will. So let's see, where is A? Right here, okay. Shoot. Why is it unknown? Just trying to get the variable. Oh shoot, but it's not in the variables because it's in the function variables. Okay. Go to the variable. Let me actually let me commit that, right? So, like, it's not good to be used, but it's not really meant to be used anyway. So I'll commit it and then make another one. So this will be progress on type. Check. Okay. Go back in here. So variable, does this have something? It does have the function that it's a part of. So we could do something with that. Right. So basically what's happening is function declaration. Let's see, where is that at? We parse them all here and we append it to the function declaration arguments. But not to that. Right. Parse variable declaration. Yeah, but we don't append it to the global variables. So we need to actually check the function variables as well. If we don't have the function, that's going to be hard to do. So we need to append it, right? Set we do set the function. So if we append to the bars, we append r the value bar. We can just check the current function. We have to know what it is though. But if I do that, then it should be in there. Oh shoot, actually can do that. Unknown variable I. Okay, where is that at? So we have a few of them. Why is the location off? I don't get that. Is there anywhere else I'm going to do this? Right. Okay. Because we know that it belongs to that. We just need to make sure it's part of the right function. Shoot. And append, yeah. So it's basically well, so I had DA append, right? Which is for dynamic arrays. And then AD append, it uses an arena. So arena DA append, basically what it means. So it's appending a dynamic array in an arena. An arena memory management things. Yeah. So basically it's just you allocate a large amount of memory up front, and then you can just append things like allocate things in there, and then when you want to free it, you just free the whole thing at once. It's basically just one big array essentially. And then that way, it uses more memory than it needs to technically, because you have more allocated. But then you don't have to worry about going through and freeing specific places. It just frees it all at once. Here I think there was. Let's see. Yeah, there is the Wikipedia page. It's pretty simple, but it's makes it a lot easier to work with memory. I can just leave that if you want to look at that. It's very cool. Like a heap space on. Well, it doesn't have to be allocated on the stack. It could be, but you can allocate it in the heap. But it's just basically one large place that's allocated. Shoot. if I do this? Rev in. Yes, we can't define variables in functions. Why is that? That is what that was. Let's see. So deck, we have that. We append it to the variables, right? Well, what do we call this? Parse var deck. We do that here. So that's a colon, then we parse that. And we should append. Do we not if it's in a function? Is in function. So we don't append it here. We could use this as well to get the name, the current name. But we can append it to the vars. Segfault. Okay. Let's see what happened. Well, does it actually compile? I can just compile it if I do that. Whoops, that's not bad. Yeah, so it's not. So it does slash main. Enable run with rule 110. Okay. Yes. I did not break anywhere, so let's see where it breaks. Gen expression. Okay, that is line 496 in, that's actually generating it. Okay, so it's not a valid expression. So I'm going to be right back. Give me about 3 minutes, then I will look into that. Yes, so right back. Okay, I am back. So, what was the GDB command you use? I need to get better at it. Okay, so, right, once you compile, you need to compile it, obviously, with the debug information, and then you can just run GDB on the executable, and then, when you're in there, right, I did 2 enable, and that way you can see it like a 2e, and you can see a lot of the stuff in it, and then R, or run, right, either one, and then you just pass the arguments that you would have at the command line. So in this case, like, I was passing the file, and then we'll run it. And then that will break it once it segfaults, if it, or whenever it stops. Or you can create a breakpoint, obviously. I'm assuming you know that. I'm not sure how familiar you are. You can create a breakpoint, like on parse or whatever. And that would break there. Yes. So basically, you wait to pass the command line arguments until you're running it, essentially. So, IUVAR function Do you use GDB when building? Okay, no, I always find debugging in 2 ways. Yeah, no, I couldn't use it. Because I've not figured out a way to get it to work. Yeah, so it makes it a bit harder. I think there's some way to do it. No matter points. Okay, I thought so. Just wasn't sure. Yeah. So I couldn't get it to work. I think there's some way to redirect basically you create a session in a different terminal, and then you basically connect to that one, but I was not sure how to do that. So I just used printf debugging and Valgrind. Okay. So why does that fail? Junction screen is complicated. I mean, you can kind of use a different process, but yeah. Yes. Same thing. Okay. So where's this at? Genvar deck. So we're generating the variable here. So without that, then it just fails, right? Okay. So if I declare them all globally, just to try it, right? Actually, it's an int. And then next in equals 0, right? And then don't define them in here. Make sure there's no that, and then is there any other things defined? I think that's it. Variable cur. Okay, I guess it is cur. So what is that? Right here, I just missed it. Alright, so cur equals alec4. So we can define cur equals 0 like that. New size. Send it to another. New size. New. Alright, then it's still site faults. Run, yes. Let's see. Okay, so it's still in the same place. So there's something here where we are doing that wrong. Might be with the command line arguments, actually. Okay, so let me go to that, right? To the func deck. That's in here, and get rid of this. So I don't want to append it to the bars, right? And then we should get an error. GDB. Apparently GDB-P will take a PID. I'll try that out properly this weekend. Yeah, alright, let's see. Okay, you can attach the process to debug from a different terminal instead of trying to run the application. Run the process as normal. When it is blocked for user input, find its process ID and then attach. Ooh, okay. And hit continue, and it got stuck. Set a breakpoint. Okay, that's pretty cool. I will definitely need to try that out, because that would be extremely useful in a lot of cases. Alright, thank you. Bar. So we need that, and then if is in function. What do we need to pass to that? Just the blocks, but we don't have the blocks, do we? Shoot. Alright, we actually we don't have it anywhere. So I could update it to use to have it as well. None of these are like, it'd be nice to have an array of the or a struct. I should have set that up. That has all of them, but I don't really want to do that right now because I don't have a lot more time because I have school soon. So let's see. Don't need it. Block stack. No, blocks. Just blocks. Okay. Blocks. Okay. Parse binary. Blocks. Okay, and then parse expression. Expression. Blocks. Blocks. Blocks already has that. Wait, what? Blocks. That's not where that goes. Okay. Bars, blocks. Then that way we'll be able to see when we're in a function, and then we can just compare that. Okay. One. Alright. Blocks. And then, but yeah, obviously I need to make a struct, like, parser, right? And then I will have the nodes in there. Nodes, variables, right? And then also the arena and things like that. And then I can just pass that, and then it would be way easier to add stuff. So that would always make a lot of sense. I need to do that. But I'm not, so I'm not think ahead very well. Blocks. Okay, that should compile now, hopefully. Maybe not. Blocks undeclared. And in, not that one. So we have, oh, we have block stack, that's what it's called. Has more. Yeah, it's all gonna be very clear. 76. Okay, what is that? 9? Alright, 957. Apparently, it's not right. $893. Okay, I just did this. Apparently it's there. 68. Alright, one more. Okay. Let's see. Blocks undeclared. 778. So this does not have the blocks. Okay. Where else? Parse bar deck. Needs block stack. I did that wrong. Hang on. Stack. There we go. Block stack. Okay. Where else? Oh yeah, so I'm gonna break the header file then. Okay. Blocks undeclared, and that is a parse native node. So that means the same thing. Blocks. Okay. In parse block stack. Okay. Parse expert 1. Blocks. That's not right. It goes at the end. Okay. Huh? Okay, blocks. Yeah, that's in the built in. Blocks. Blocks. It's built in. Blocks. Okay. Now, if I did this. Alright, this isn't one there. Good. It does compile now. So, was I? Oh yeah. So then, get involved. So if we pass the blocks here, blocks, then we can do that, and we can iterate over. So that's then blocks.count. Actually, just recheck if is in func blocks. Then we want to iterate over the topmost function arguments as well. So for I is less than shoot, we don't even have that, do we? Hang on, is in function is what it's called actually. Alright, it's in the function, so functions data that, and we need to iterate over the arguments of that. Data that dot, what are the fields called in the function? Args. So we need to iterate over the args and get the variable names. Yeah. So args.count. So let's see. And then we need to do that and get the name. So if we compare functions data, let's just get the function here. So function func equals functions dot data functions dot count -1 dot arg dot count. Let's actually assert that functions dot count is greater than 0. Let's see, functions are out of whack. Okay. Yeah, that shouldn't trigger, right? Because that means something messed up in the parsing, right? So we can use that thing. So use func. Func.args.data I dot value dot var dot name and compare it with his name, and then return that func.args data I dot value dot var. Okay. And let's see, does that work? No. Two key arguments to get var. Oh yeah, so I need to update that. Get var, I need to pass the blocks first of all, and implicit declaration of isIn function. Sure, we don't have the functions here, do we? Functions. Okay, and then this. What is that about? Functions is a pointer, yes. Alright, and what else? Valid initializer. I need to do that. So why is there conflicting types? Grab that. Put it in here. Yes, I don't have it, so that's why. Okay. And let's see. Now we are stuck. Ooh. It's at the runtime. Okay. So something got messed up in the... Okay, that's interesting. That works out. Tim. That's kind of higher. Whoops. No. 10. Yeah, okay, so it prints out that, and then it freezes. So, interesting. If I do that on... Say false, okay. Oops, I didn't mean to put it in the source. What happened? I replace company fat to vehicle. That's what I want. Alright, let's look at compile. It does. Okay. uv./main, enable, run. Okay. Yes, and where does it break? If that. Okay. Did I mess this up? Hang on. Value.var. We go here. What do we do stuff? Hey, let's see. Func deck, and we append to the value func deck args. Append to the function. And what do we append the function at? We append the function there. To append to the function, and then why can we not access it? Break on if long. Then run again. Yes. Is in function. Okay, and let's print the A, which is A, and print functions. Count, which is 1. Okay, print func. We don't have func yet. Print func. That's not even right. Strcomp8. Why is it like that? Oh, okay, because it's strcomp, yeah. And that is just stuff that comes after it. Because it's a string view. Alright. Let's view. Print. I can't print that. View. Print. I just want to make sure it works, right? Arg. Func dot name. Okay, that does one. Whatever, it's fine. Let's see. Function args count. Func args data that. Func dot args dot count. And print func dot args dot data I. Dot args dot data I dot value. Args dot data I dot value dot R. Dot value dot R dot A. So that is one. It's ready to take fault. Alright, but then it just returned it. So that one failed. That one did not fail. Print func count. Count. It's 1. Print func. Still string compare. It's not data I. It's A. What is the name? It's I. R data I. Of R is that R is that data I 1 dot Y. I mean value. Okay. Is B. The name is I. Oh shoot. Okay. Because you don't append that. Yeah. So that's why it fails. How many R's are there? How does it go forever? What? I. 7. What? Oh, I forgot to do I. It's less than that. I is less than. Oh, it's can't. Yeah, okay, that's not good. Yes. I'm gonna go I. Yes. Okay, so that is because I need to append it. So, okay. Let's see. Where is it? Yeah, bar down. Bar down, actually, right here, and then we need to do this. You can also. Okay, that did not quite work. It didn't segfault though. But yeah, I do actually have to go. So I'll commit this. Oops. That's not right. Okay, no screen. Progress, function. Yeah, not function. Checking currently some issues with, Alright, so I'll push it. It's broken obviously, but anyway. Yeah, so I do have to go. So thank you guys for watching, and I'll see you next time. Goodbye.